A very good morning to one and all. Welcome to 2 week student development program on emerging engineering the future, moving from electronics design to industrial implementation, organized by Department of Electronics and Communication Engineering, Dayananda Sagar College of Engineering, Bengaluru. Today we have with us Mr. Sagar, who is a graduate in Electronics and Communication Engineering from Dayananda Sagar College of Engineering, Bangalore. Currently, he works as a technical support engineer at Andritsu, where he utilizes his technical skills to provide innovative solutions and exceptional support. With a strong foundation in ECE, he is passionate about staying up to date with the latest technologies and contributing to the growth of his organization. He is excited to continue learning and growing in his role, delivering high quality support and making a positive impact in the industry. I welcome Mr. Sagar. Please proceed with your presentation.
Thank you, sir. Thank you so much. Good morning, students. So my screen is visible. It is in present mode, or
no,
is in?
It's not in presentation mode. You can make
I want
it.
to confirm.
Okay. Full screen you can make it. Presentation mode.
Hello.
Full screen presentation mode you need to make it.
Okay. I will change it to entire screen. Wait a minute.
No, nothing is visible actually.
Now you can see, right?
Now I can see. Yeah, please proceed.
Okay. Thank you, sir. Thank you for the introduction. So, guys, you already know, right? My name is Sagar. I'm from Andritsu, Technical Support Engineer. So today I'm going to brief you about what is optical communication, what is the principle, how it works, and I'll give a brief product overview, like we are selling in our company. So you'll get the knowledge of that. So we start the session. Anytime. So if you have any questions, you can pause me and you can ask me any questions. So let's start the session. So for this session agenda is to introduction of the optical communication and what is the principal operation of the optical communication and what is optical fiber, how it looks, what is inside, how it works. I'm going to discuss about it, and we'll discuss about the comparison about the fibers and other cables. And this one is also important parameter splicing and couplers. I will discuss that, and we'll after that we'll introduce the product overview. So which is our product. I will brief about how it works and what is the product, what is the applications and all. So this is the agenda of this today's session. Okay. Before going to that, so first of all, optical communications. So it is invented or demonstrated by Daniel Caldano and Jacques Babinet in the early 1840s. So these two guys are demonstrated the optical lights in a fiber, how it will go and how it will work, how it will reflect and how it will come back. So these guys are introduced this like demonstrated in the early 1840s. This will help us to achieving further technologies. So optical fibers are widely used in a fiber optic communication, which permits transmission over a longer distance and higher data rates than the other forms of wired and wireless communication. As you know, So the optical fiber, the biggest advantage is bandwidth compared to the wired or wireless communications. You might know that. So it is having a biggest bandwidth. It covers the biggest bandwidth compared to the wire and wireless. And the optical fibers are long, thin strands of very pure glass, usually 120 micrometer diameter. So these thin strands, like size of our hair, like that the optical fibers have that size. But after the coating and after the sheet and all, it becomes larger. But if you compare only the optical fibers, it is the size of our hairs, and the diameter is 120 micrometer in diameter, overall diameter. If you compare only core and cladding, I will brief about in next slides. So they are arranged in the bundles called optical cables and used to transmit light signal over a long distance. So you know, right, optical means light only. Here we are using the information source as a light, and we are transmitting it in a optical fiber. And the principle of light transmission to the optical fibers based on the reflection and the total internal reflection enables efficient and high-speed data transfer. So it is totally work on the principle of refraction and internal reflection. We'll talk about it later in the further slides. First we'll know what is the difference in the common communication and the optical fiber communication. So in a common communication like wired or wireless, anything you can take. First, we will have the information source, that is transmitter.
Hello.
It goes to transmitter and modulates it like carrier adds and the
Okay, sorry man,
frequencies,
accidentally
and
called
it
you.
will modulate
Uh,
the information. And then it transmit via medium, via wired cables, copper cables, or Wi-Fi, anything it can take. And then it comes to receiver and demodulate the information, and it sends to the destination. This is how normal communication works. But when it comes to the optical fiber communication system, so here the information source is given to electrical transmit. Here what we'll do is this optical source, it will convert the electrical signals into pulse of lights. Like you can take anything, if it is any information is there, it will convert that electrical signals into optical pulses. Then it travels to the optical fiber, because here
what
we are
is this?
using a copper wires and some other cables.
Are you?
Here we are
Where
using
are
a
you people?
copper optical fiber cables that used to
Are
transmit
listen.
only light.
When you come,
So that
okay,
will light
ask
passes
that
here.
Pavitra madam at least that you will take her for lunch or something. Okay.
So the light
It doesn't
passes
look good
through the optical
like that
fiber
you are
cable, and
because
then
my
optical
batches
detectors.
they have
These are used
firstly
to
they have
detect
asked
the
and
light
they are
signals.
taking
So
us out
these
to
are very
lecture.
highly
Okay.
sensitive and
It
quite
doesn't look
expensive
good.
also.
Okay. At least she has
So
helped
optical
two people
detectors
like me. I
such
can't
as like you
understand.
can take
Okay. You just ask
photodiode,
okay when
phototransistor,
you come. Okay. Don't
uh,
tell I told you.
coupled
Okay.
device, charge coupled
You
device,
understood right?
avalanche photodiode.
But all
These are
four
some
should
of the
come and
examples of
do it
optical
like that to her.
detectors.
Okay.
So detect the
Okay.
lights,
Yeah.
pulses
Okay.
of lights, and then again it reconvert into electrical signals, and then it goes to destination. This is a very simple compared to the other communication system with the optical fiber system. Now we'll discuss how
Yeah.
the
We'll
light will passes in the
हम
fiber.
honestly, अरे you
See,
people
as I
listen,
told
you
before,
people didn't
total
even
internal
ask
reflection.
that
This is the
why
principle of
come?
operation.
Where are other?
So when the light passes in the, this is actually
Event.
code.
Ask madam
It's
for
looking
lunch or
bigger here,
something.
but I'll show
Yeah, so
the
she was like,
actual size after.
what are
So
you
this
I
is the
can't
light.
see my
Okay,
other two
so
batches. They
this
are
light
taking us
source
out
is
today.
passing
You know.
from here,
Yeah,
but it is not
I can't
reflecting back here.
that
It
also
is
I need to
going
tell.
and it is
It look
leaking,
very
going
bad
somewhere.
actually. You know, she
So
has
here
helped
one
you people like me.
important term
What
comes,
you
that is
people?
critical
Okay,
angle.
you
So
go.
I'll just tell
Yeah.
you. Okay, so total internal reflection is a phenomena that occurs when the light wave traveling through a medium hits the boundary of the less dense medium at the angle greater than the critical angle. So means what is the critical angle is the minimum angle of incident at which the total internal reflection occurs. So as you can see here it is also reflecting back, but some of the light is leaking there. So this is not a critical angle and it is not total internal reflection. So this is an important parameter. So when we achieve this, we can pass the light in the core only. Then it cannot leak anywhere. So as you can see here, this is a total internal reflection. Here at a right angle, we are passing the light and it is bouncing back here and it again bouncing back here. Like this, it is doing now. Same thing. So we have to achieve this total internal reflection of light. Then only we are going to transmit the light in the optical fiber. Otherwise, we'll lose the information. We'll lost the information. And why I am telling this, because our product is related to this only, and it will check what is the losses, what is the fiber looks, what is the fiber behavior, what is the integrity of the fiber. So our product mainly made for this purpose only. So that's why I'm telling all these technical things. So I'm not going to deep in the technical things. So I'll tell you on only the basics. Okay, and so this is the optical fiber, how it looks like. So as you can see here, as I told, this is total 125 micrometer, the diameter, as I told before. But this is the optical fiber core. This is only tiny size. It is the size of our hair. Like it is the diameter of 8 to 10 micrometers. As you can imagine, how much the 8 to 10 micrometer it would look like. Okay, and then the core of the conventional optical fiber is cylinder. As you can see, this is a cylinder and of a glass and a plastic that runs along the fiber's length. So these are outer jacket and stanton member. These are all plastic. And uh, surrounded by a medium with a lower index of
Ananya,
refraction,
where are you?
typically cladding of a different glass or plastic.
Okay, okay, fine. Once
This
you finish, you meet me.
after that core,
All of us. Okay.
this comes
Yeah.
the cladding. This plays the major important role because this is the what we call the cladding different medium with a lower index of refraction. Now, this is the lower index of refraction, and the core is highly uh, uh, like higher reflexive induction. So here you can see cladding is one more layer of materials of lower reflexive index in time contact with the core material of higher refractive index. So then only we can achieve the total internal reflection. So we have to do is that light, whatever information we are passing it through this core, we have to trap inside the core only, like this. It's the light ray. We have to trap it inside the core only, and we have to pass it. So that's the main thing. It's the main goal of this optical fiber communication. So we have to achieve this. The cladding causes light to confine to the core of the fiber by total internal reflection at the boundary between the two. So as I told, we have to trap the light inside the this core. It will not go anywhere. It has to bounce back and it has to travel to the this fiber cable. This is all the concept what we have know till now. And then there are types are there in optical fiber. So coming to the types, there are two types depending upon the propagation of the modes: single mode and multi mode. As the name says, single mode, it is the its core is like 9 micrometer only. Like its core is very thin. Coming to multi mode, its core is bigger.